All right, welcome to 7.3, Proving Triangles Similar. These should be pretty short notes here. Proving triangles similar is a lot like proving triangles congruent. And at first, what we told you is that we can only prove two things similar if all the corresponding angles are congruent and if all the corresponding sides are proportional. Actually, that's not entirely true. We can do it more quickly. What we can do is instead of having three pairs of sides and three pairs of angles and talking about all of them, what we can really look at is just a couple of the angles and or a couple of the sides. Just like when we talked about triangle congruence, where at first we said all the angles have to be the same and all the sides have to be the same, then we told you, well, actually you could do SSS or SAS and that's good enough. Same thing here. So the first one for triangle similarity, the first shortcut is angle-angle similarity. Long story short, what this says is if you can find two angles that are congruent in one triangle to two angles incongruent in another, they are automatically similar triangles. End of story, walk away. So in this case, R is congruent to L and T is congruent to P. There's two pairs of angles that are congruent. The triangles have to be similar. Therefore, TRS is similar to PLM if I follow the correct order. Side angle side similarity isn't used as often, which is why I really would like you to draw stars next to this one because that's where we usually head. But sometimes you don't have two angles, you only have one. In that case, if you can do side angle side similarity, that means you show that you have one angle that's congruent in two triangles, and then the sides including the angles would have to be proportional. So if I had an example over here, let's say I looked at these two triangles right here, if I knew that this angle was congruent to that, and I knew that, let's say, this was 1 and this was 3, and that's 5 and that's 15. These would be proportional because each of the sides was tripled and the angles match up. This would be SAS similarity here. The triangles are congruent, but they are similar. So long story short, if one angle is congruent to another and the sides are proportional, then the triangles are similar. On the same vein, if you didn't know any of the angles, you could do side-side-side similarity. And that's the idea that if I had 4, 5, 6 here, and 8, 10, 12 here, all of those sides got double. If all of the sides got double, that's going to maintain proportionality there. So this is the side-side-side similarity theorem. If all, and really the word all is implied here, if all the corresponding sides of two triangles are proportional, then the triangles are similar. What's important to note about all these is that this only applies to triangles. It does not apply to quadrilaterals or anything like that. So coming down here, using the angle-angle postulate, are these two triangles down here similar? Well, I have to figure out if I can find two pairs of angles that are congruent. Well, let's see. MX is perpendicular to AB, so I have a 90 and a 90, a 58 and a 58. As soon as you have two pairs of angles that are congruent, the triangles are automatically similar. So one triangle is similar to the next. My similarity statement is going to state them in the right order. So if I said AMX for the first one, AMX, I would have to do BKX for the second. Explain why they're similar. We could just say they are similar because two pairs of angles are congruent. And the shorter way to say that is they are similar by angle-angle similarity. Last but not least, on the front, we have these two. Are these triangles similar down here? Well, I have the bow tie, so I automatically have these vertical angles, but I don't have any other angles. So now I've got to look to the sides, and this is probably looking like side angle side similarity if I can find proportionality here. So when I go to set up my proportion, I want to compare the appropriate sides. So if I look at 12 from this triangle on the left, 12 is smaller than 18, which means I need to look at the smaller of the other two values. 12 is smaller than 18, 24 is smaller than 36. So I'd say 12 to 24 and 18 to 36. If those things are proportional, if that equation is true, the triangles will be equal. So let's see, 12 to 24 is 1/2, 18 to 36, also 1/2. So triangle 1, 2, 3 is similar to what triangle 4, 5, 6, we'll name it in a second, by side angle side similarity. two sides and their included angle are similar to two sides and the included angle of another. So if I called the first one ZVY, be careful, ZVY would then go with X. Z and X are corresponding there, XVW. And the reason that I have to order it like that is I have to make sure that I deal with the small sides first. ZV is right here, 18 is the bigger side, so 36 is the bigger side. That's why XV needs to come first on the right. If you hear a ding in a second, that's just the bell ringing. Please ignore it. Onto the back, very quickly, we have similar triangles with somebody looking in the mirror. Setting up this picture is pretty challenging. So it says that Joan is placing a mirror 24 feet from the base of a tree. And then she stands 3 feet from the mirror. So that's 3. This whole thing is 24. And if she is 5 feet up, and she looks in the mirror, she can see the top of the tree. So my figure looks like this. Technically, I have two triangles right here. I have this baby triangle. What just happened to my computer? I have a baby triangle down there. Sorry, I had some technical difficulties on my end. I have this baby triangle down here, which has a right angle right here, a 5, and a 3. And then I have the larger triangle that includes the tree. And if I draw that over here, this angle is the same as the one down there because they are shared. This is 90. I know this is 24. And they are asking us what? If her eyes are 5 feet above the ground, how tall is the tree? Well, the tree is this height right here. So I put an X there. And now I just want to solve for X. So I'm just going to set up a proportion. The reason I know I can set up a proportion is because I have two pairs of congruent angles. So by angle-angle similarity, these two triangles are similar, which means I can set up a proportion. 5 over X equals 3 over 24. To solve a proportion, I just cross multiply and solve. So 5 times 24 is 120 equals 3x. Divide by 3, and I get 40. The tree is 40 feet tall. Explain why those triangles are similar. Write a similarity statement. All right, I don't know any angles, so it's absolutely not angle-angle similarity. Don't know any angles, so it also can't be side-angle-side similarity. So my only option here is to hope it's SSS similarity. So let's compare the corresponding sides. 6 and 8 would be corresponding. 6 and 8 would be corresponding. 9 and 12 would be corresponding. If all of these are equal, then I know the triangles are similar. 6 over 8 reduces to 3/4. This reduces to 3/4, as does 9/12. So by SSS similarity, the triangles are congruent. I'm sorry, triangles are similar. And a similarity statement would be that triangle, let's call it GEF, would be similar to triangle CAB. You could also say CBA. That works because of the fact that this is isosceles. And look at that last one. In the sunlight, a cactus casts a 9-foot shadow. Oh, a cactus. It's probably much warmer there than it is here. Cactus casts a 9-foot shadow. At the same time, person 6 feet tall casts a 4-foot shadow. Use similar triangles to find the height of the cactus. All right, so why are these similar? Well, they have a 90-degree angle right there. And since the sun is up here, wow, the sun, we haven't seen that a while in here. Since the sun is up here, it's going to cast a shadow down, and that shadow is going to maintain the same angle of inclination. The angle of inclination of the sun is the same for both of those diagrams. So by angle-angle similarity, the triangles are similar, which means I can set up a proportion. So if I set up my proportion, 6 would have to go with x, the height of the cactus. 4 would go with the length of the cactus's shadow. Cross multiply and solve. 54 equals 4x. Divide by 4, and we're going to get x equals 13.5. All right, so what did we just do? We just talked about similarity. So if I skip to a blank page here for a second, we just talked about similarity. What you need to know is that two triangles are similar if two angles are congruent in each triangle. That is called angle-angle similarity. Huge. Going to use it all the time. Angle-angle similarity, two angles equal to two other angles. Triangles are automatically similar. Angle-angle similarity. If you don't have enough to do angle-angle similarity, there is also side-side-side similarity and side-angle-side similarity. For each of those, you would need to show 3 pairs of ratios are equal, or you would need to show 2 pairs of ratios equal, not pairs, but 2 pairs of sides equal, making the same proportion, and you would have to show that the angle in the middle is the same. However, I gotta be honest with you, angle-angle similarity is absolutely where it's going to be from now on, so make sure you know how to use it. Have a great night, and I will see you tomorrow.